Hello again, this is the Vintage Tech, and we're in the shack working on a Crosley radio. I should have taken a picture of this before I started on it, but I got into it and I thought, you know what, I need to do a video on this repair. This is a 3-tube regenerative receiver, and I'm going to turn the set around and take some photographs of it before I pull it apart. But the chassis pulls out of the front of the radio. That's pretty obvious. But these sets, these regenerative sets, were notorious for blowing out the interstage transformers. And I did a repair on an Atwater Kent regenerative receiver. It's here in the shack. I'll give you a shot of it. And I had originally bypassed a couple of the open windings with a capacitor and a resistor to get the set running, but that's not ideal because the gain is reduced in doing that, but it works and it's a great temporary solution. Well, what I discovered on the Atwater Kent was that I could actually buy a exact fit replacement transformer and put it in the case of the transformer shell, and you can see the shell here has a metal cover, nice metal cover that's bolted in, and the terminals come down here and then go up to the transformer. I'm going to take this apart and see if the wiring goes into the base of the transformer. The transformers that I bought for the Atwater Kent, I think, are still available. They're not cheap, $20 a piece or something like that. And I need two. Both of the secondaries on the two interstage transformers in this radio are open. And so the set can't operate. The cathode, the voltages that pass through the transformer, the DC voltages that pass through the transformer to drive the tubes, of course, is missing because the windings are open. So what I'm going to do is open one of these transformers, and I'll just take the shell off of it off camera, and then I'll let you take a look at what these look like inside the shell. These are original Crosley transformers. You can see the Crosley writing right on the side there. Yeah. And let's pull this apart, and then we'll be back and take a look at it. All right, here's the Crosley 52SD Super Deluxe schematic. It's very simplified. 3 tubes and the interstage transformers here. And the filaments that are burned out are these two secondaries right here. So this secondary, so the power comes in, the A and C power comes in off of the power supply and supplies the grids, both power to the grids. So those are completely open, so there's no power getting to the grid. So the tubes may be lighting up, but they're not turning on because the grid is shut down. So that's the issue. Both of these filaments, both of these secondary windings are open. Okay, here's the transformer. You can actually pull the core. I'm not going to because I don't want to chance not being able to put it back together, but there's the transformer. This is the secondary that's open. 480 ohms, I think, on the primary. But we've got to find this transformer. So I think I can find it online. I'm going to check it out. I'll let you join in on that search as well. But That's a pretty common failure with these regenerative receivers. So let's see, we got felt here and wax paper that covers the windings. You know, I probably could, oh my, yeah, probably could pull the paper off and see if there's a broken wire and maybe try to fix it. But who knows what I'll find when I get in there. Yeah, there's the end of the paper. I think I could pull that back. You know, I might just try that. I have nothing to lose because I've got to find a transformer that will work in this set to get the set working again. And I'd love for it to be original inside that Crosley cover. So that's the plan. I might just open this up and just see if I can luck out and find a broken wire at the very top of the wrap. I'm not sure with the secondary, if the secondary is on the outside of the transformer or on the inside windings. It's hard to tell by looking at this. I'm just not sure. But I should know once I pull this paper off. So that's, I think, what I'll do is I'll pull this paper off and we'll see if we can get to the windings and maybe just solder the windings back or something. Let's see what we can find out. All right, we're going to pull the core out of the windings and set those aside. And I'm trying to see here what's going to be involved in getting access to some of these outer windings. Hopefully, if the tape will come off, I might be able to see if there was a burn spot. And after quite a bit of fiddling, I decided to just go for broke and use an X-Acto knife and see if I could get some of the wax paper off of the top layer of windings. And when that didn't work, I decided to apply some heat with the soldering station to try to melt the wax and be able to remove the paper that way. I didn't have much luck with that either. What this appears to be is an inner set of windings on the primary, and the secondary are all of these windings. Let me get on camera and get in focus. All of these windings here, this fatter outer band is the secondary, and the primary is a small set of windings on the inside of this core. It's consistent with what we saw on the drawing. So you can see the differentiation between the inner and outer, primary and secondary. I continued to dig until I got into the top layer of the actual transformer wire. So thin. I can't even see the end of the wire. Yeah, it's so thin. Okay, that came off, but the wire is there. Can you see it in the video? Right here. Let me zoom in. Yeah, there it is. That's how thin the transformer wire is. And this is what was connected to it. So you can see how big it is compared to so the connecting wire was soldered on there. It was pretty clear that I wasn't going to be able to be successful in trying to find a broken wire with it being so thin and so difficult to dig out. And as I continued to dig, I saw what looked like a piece of ribbon. As you can see here, it looked like a piece of ribbon, and then all of a sudden I discovered that it was a whole bundle of wires. It's a whole bunch of wires. Look on my thumbnail. See, yeah, so it's a whole bundle of enamel coated wiring. it's just probably thousands of windings there. So we're not going anywhere with this transformer, I can tell you right now. So I have two choices here. If I can't find a transformer that will work in this radio, which I feel pretty sure I still can, I can button it back up, maintain the integrity of the primary, and then just bypass the secondary altogether with a resistor and a capacitor. And there are plenty of videos on YouTube that describe that process. Of bypassing the transformer and open winding. And it will work. I'm not saying that it doesn't work, because I've done that with another radio. I've got another radio over here that I didn't have, couldn't find a transformer for it. And I had to do that on it. And it worked. It worked. It wasn't perfect, and it wasn't real loud. The gain wasn't real great, but it did work. So, all right. Well, now that we know what a transformer looks like inside, which is no surprise, that wire is just hair thin and just too thin to work with. Would have been fun to try to fix that primary or secondary. So let's go to the computer, and I'll see if I can find transformers that I bought 10 years ago. Man, I hope they're still available. Here we go to the Radio Days website, and I did a little bit of research and found that a model number would be helpful for the replacement transformer. So I've pasted that in here, and this is the transformer that I need. This is designed to come without a core, and you can use your own core in the transformer, and you can see it's $25. So if we jump right back into the website and look at the technical specifications, we can see that the primary is 400 ohms, and the secondary, if it weren't open, would be 1500 some ohms. And that is consistent with what I was reading on the schematics. We won't use the center tap on the transformer. We'll just use the outer terminals. And you can notice here that this is an interstage transformer, and what is typically used for up to 124 volts. And it's used as an empty core. You use your own core and insert it inside the windings of the transformer. I've mentioned a couple of times that the way that we bypass the open winding, broken winding in a transformer, in an audio stage or an interstage, by that we're talking about in between the two stages of audio, here a tube, and then an interstage. So we have an audio signal that comes through here, and then the audio and the DC voltage are both passed through this winding into the plate. So the plate transfers audio, and the DC voltage is transferred. This 45 volts, 16 to 45 volts, is energizing this plate. The audio passes through the transformer inductively into the secondary winding, and then the secondary winding, there's an amplification that occurs there, and the secondary winding transfers that audio signal over into the grid of the tube. Additionally, there is a voltage that is necessary to turn this grid on, to turn the tube on. So we need both a DC voltage here, and we also need some way to get AC, the audio signal, from this side off the plate over and through the transformer. Well, we can't inductively transfer that signal anymore because these windings are open, and there's no way to repair those windings, as we just discovered, at least not this time. And I have fixed some of these before. But in this case, we're not going to mess with that. So either we need to replace the transformer, or we can take a capacitor and connect it here on the primary side and come over the top and into the secondary so that the audio signal passes directly over and into the next stage. Now, there's no amplification that occurs if the transformer is designed to boost the signal, not only isolate it, but boost the signal. That capacitor will only pass DC voltages into, or AC voltages, or the audio signal into this next stage. Well, we still need a negative voltage on this tube to turn the tube on, and with this winding open, we're not able to do that. So what we do is we take a resistor that is a high enough value to not short the audio signal, but a low enough value to pass some DC voltage into the tube. When we tie that across the windings, in other words, all we're doing is taking a DC voltage and going straight into the tube. These windings, 1500 ohms, is not enough resistance to attenuate the voltage that needs to be applied to this tube. So what we're going to do is we're going to put a resistor of similar resistance. Now that was DC resistance. It's measured there. And we'll put a resistor across these terminals here, or these points here, to drive this tube. And then we have our capacitor that bridges the audio over into the tube. The challenge we have here is that we've got two interstage transformers that are open. This secondary is also open. So we would have to do the same thing here. This plate drives through the earphone jack, and if the headphone jack is not being used, you can see that that signal goes right back into this second stage of audio. Now, let me say this. Most of these regenerative receivers used a headphone jack and a speaker jack. That's what these two terminals are. They're speakers. The headphone jack the headphones are very sensitive, and you don't need a lot of volume on headphones because you got the speakers, the drivers, right up against your ears. So they would only use one stage of the amplification for audio. So this is the first stage of audio, goes up to the plate and into the headphones, and then it disconnects the speaker. But if we're not using the headphones, the signal path goes like this. It comes up through here, down, and into the second stage. Then it is coupled to the second amplifier to drive the speaker. I'm sure that makes sense. As you look at the schematic, you'll see where the signal path goes. So the regenerative signal comes through this tube that amplifies the signal as we tune it with this. We've got two tuning devices that adjust. We've got an RF tuner, and then we've got these transformers. It's really a transformer that's adjustable. It's not a capacitor. And then that adjusts the signal. This amplifies that signal and brings it over to the first interstage transformer. And then that's coupled inductively into the first audio amplifier. And then if we don't use a headphone, it then is transferred into the second interstage transformer, inductively coupled into the second audio stage. Now, I was talking very quickly, and I may have misspoken, but I think I may have missed a term here or there, but I think you get the idea of how the circuit works. So if we were going to not replace these transformers, we would need to put a cap here and a cap here, so that we have audio path into and through each of the interstages. And then we would need some kind of DC coupling to bypass this open terminal, this open winding and this open winding. So we'd need a resistor here, and we would need a resistor here to pass this minus C voltage up into the grid of the tube.